extended Backus-Naur form is just like BNF, but with some convenience. It's not more expressive than BNF, but the grammar descriptions can be shorter, and they might even involve fewer symbols. Instead of carefully going through every item, I'll just show you what the docs are. You can read about the details, but it's possible to group items, which means then you could repeat them. It's possible to put items in brackets, which means that you either have them or you don't. And you can use some of the operators from regular expressions, but on symbols. 0 or 1 instances of a group or symbol, 0 or more, 1 or more, exactly n, n to m, just like a regular expression. And this eBNF is used quite often. For example, you can find it even in the Python docs, in the part that describes what expressions are allowed in Python. So here's a description of the syntax for dictionaries. In this variant, instead of a colon, there's 2 colons and an equals, but you get the same idea. You have the opening and closing curly braces. Contents is optional. You could just have open close for an empty dictionary, or you could have a list of key value pairs, or a dictionary comprehension. And a list is 1 item, and then a comma and some more items. This is a group, which is optionally repeated, and you're allowed to have a comma at the end. A key value pairs is an expression for the key and an expression for the value. Now we're in a good position to write down the grammar for the calculator language. First, a few more specifics of Lark. Lark supports some common terminal types such as numbers via import directives, so you don't have to write down the regular expression for a number. You just have to import it. And some symbols start with a question mark in their rule. These are special because they do not show up in the parse tree if they have exactly 1 child. So you can have a chain of A goes to B and B goes to C and C goes to D without having the parse tree include that long chain, as long as you put question marks before the symbols. Here's the grammar for calculator. An expression is either a number or a call expression. A call expression has parentheses, an operator, and some operand expressions. We'll ignore white space, and a number is the common notion of a number. So the expression 1 plus 2 times 3 is a call expression plus 1, 2, another call expression, times 2, 3. And where are the nodes for the expr symbol? Well, they have been omitted because of this question mark. If I took out this question mark and ran this again, adding 1 to the result of multiplying 2 and 3, now they're there. An expression is a call expression, which is plus, or an expression which is 1. Okay, so you can see all the redundancy here, which is why this feature exists that allows you to get rid of all the expr nodes, but still use them in the definition of the grammar so that you get the right tree structure.